In this session, we will discuss about fiber fabrication technique. In the previous session, we have discussed one of the fiber fabrication technique, that is outside vapor phase oxidation, that is OVPO, or outside vapor deposition, or OVD. And we have discussed about that. And there are other three methods of fiber fabrications, that are vapor phase axial deposition, which is also called the VAD. Next is modified chemical vapor deposition, MCVD, and plasma activated chemical vapor deposition, or PCVD. And in this class we will discuss about other three methods such as vapor phase axial deposition, modified chemical vapor deposition, and plasma activated chemical vapor deposition. And in the previous case we have discussed that in the case of outside vapor phase oxidation, the silica particles are deposited outside the glass tube. And here this is a setup for vapor phase axial deposition. You can see the setup for vapor phase axial deposition. So you can see here that this is the apparatus arrangement. Here you can see that there is a pulling machine and the motor hold the seed rod, which is a glass tube, that is the seed rod, and there is a transparent preform, and next is a vessel. That vessel contains the entire setup, and there is a ring heater that is used for sintering process, and the exhaust is provided there. There is a thermoviewer in order to monitor the temperature, and glass particles is also shown there, and there is a reaction chamber, and the inside the reaction chamber glass particles are deposited. There is a torch, and the silica particles are originated from this torch, and a porous preform is also shown there. These are the different parts of this apparatus. We will discuss the working with the help of this diagram. See, first of all, vapor phase axial deposition is also called the VPD, vapor phase axial deposition or vapor phase deposition, and it is the OVPO process. It is it is similar to that of OVPO process, and OVPO process is, we find that OVPO process takes place in a lateral manner. That means glass particles are deposited in a lateral fashion over the glass tube. And another OVPO process is the vapor phase axial deposition process, or VAD, and it is done in a closed environment. We know that in the case of OVPO process, glass particles are deposited over the glass tube, and it is in an open environment, so the surface contaminants will be there in the case of OVPO process. But in the case of vapor phase axial deposition, glass particles are deposited inside in a closed environment, so the contaminants or external contaminants will be less in this case comparing to that of OVPO process. And here also, as in the case of OVPO process, SiO2 particles are formed by the same reaction. Those reaction is shown in the next slide. See, and here the reaction are SiCl for reactive with oxygen to produce SiO2, and also germanium chloride reactive with oxygen to provide germanium oxide. So this two forms the soot, and also this takes place in the form of in dry oxidation method, and in the presence of water or steam, water vapor or steam, it will produce SiO2 and GeO2 like this, and the chemical reactions are shown here, and the chemical reaction takes place in the same manner as that takes place in the case of OVPO process. So we can find that SiO2 particles will be there due to this chemical reaction. That means that is a silica particle or glass particles. So see here, so SiO2 particles are formed in the same way as in the case of OVPO process. In this case also, see here, there is torches are provided here. You can see here, see, you can see torches are provided here, and these torches will give the SiO2 particles, and it is shown here. So it will give a porous preform, that is porous SiO2 particles are formed by this reaction. So it will be deposited at the end of a glass rod, that is seed rod. So here deposition takes place in the axial manner, not in the lateral position, and also once it is deposited, the glass rod is moved up and down position, and also it is rotated in a circular movement also, so that the glass particles are deposited in a uniform manner. There is also inside this chamber there is a ring heater provided here. This ring heater will heat this deposit or soot deposited will be heated by the temperature provided by this ring heater, so that it will be the soot will be sintered into a original glass preform. So the rotating movement will be controlled by the motor provided here. So this is a process that is actually taking place in the case of vapor phase axial deposition. So the SiO2 particles emerge from the torches, and these particles deposited onto the end surface of the silica glass rod, and which act as a seed, and a porous preform is grown in the axial direction by moving the rod upwards, and the rod is also continuously rotated to maintain the cylindrical symmetry of the particle deposition. You can see that in the case of OVPO process and in the first method, the silica particles are deposited outside of the glass rod, right? And here the silica particles are deposited at the end surface of the glass rod. So as the porous preform moves upwards, it is transformed into a solid transparent rod preform by zone melting. And zone melting means there is heating takes place, but heating takes place in a narrow localized zone only. And this heating takes place with the help of carbon ring heater, and this process is called sintering. In the case of sintering, the soot will be transformed into original preform, glass preform. Okay, the resultant preform can then be drawn into fiber by heating it in the another furnace. So we got the original preform by the process of sintering, and here this preform or glass preform will be given to the fiber drawing apparatus, and this figure is shown here, and from this fiber drawing apparatus we can draw thin precise fibers, and I have explained the working of this fiber drawing apparatus in the previous classes, so I am not going to the details of it. I provided this diagram in order to remember you about this fiber drawing apparatus. So this is all the process taking place in the case of vapor axial deposition. Remember that in this case axial deposition taking place, and here all the processes are enclosed within a chamber, so that is there will not be other contaminants from the outer side or outer environment. So here also same as in the case of OVPO, here also soot formation is taking place by the chemical reaction given in this diagram, given in this picture. So next we will go to the advantages of the VAD methods, and the advantages of the VAD methods are both the step indexed and graded index fibers in either multi-mode or single mode varieties can be made in the case of vapor phase axial deposition, and the preform has no central hole in the case of VAD method, but you know that in the case of outside vapor phase oxidation method there is a central hole there, but here there is no central hole in the case of VAD, and preform can be fabricated in a continuous length in the case of VAD. Also deposition chamber and zone melting ring heater are tightly connected to each other, and they are in the same enclosure, so that clean environment is achieved. So that is all about VAD method. Next we will go to the MCVD method, and the experimental setup for MCVD method is shown in the figure. Here you can see that there is a traversing burner, and also the sintered glass is there, bathed tube is there, also reactants are metal halides and oxygen. You can see that here metal halides and oxygen are provided inside the seed rod or bathed tube, and soot formation is taking place inside the seed rod or bathed tube, and here you can see that the exhaust are going outside, and also here a ring is shown. That means it is rotated in such a manner. Okay, so we will go to the details of MCVD process, that is modified chemical vapor deposition is MCVD. So unlike the OVD, the glass particles are created in the case of MCVD by burning the metal halides in oxygen inside the silica tube. That means here the process takes place inside the silica tube, and here the burning of the metal halides will provide, along with the oxygen, provides the soot. Okay, you can see that the metal halides and oxygen are going into the tube, and in the presence of traversing burner it will be heated and it will give a soot. And here for the process, first we will take a hollow silica tube, and we will clean it, and this silica tube is then placed on a specialized lathe, and gradually that lathe is moved along its long axis. Gradually that glass tube is moved along its long axis, and at the same time the glass tube is heated externally by a movable torch or by a furnace, and the temperature is of about 1400 to 1600 degrees Celsius, so that it is heated, that glass tube is heated, and the heat source is slowly moved in a continuous fashion along the length of the tube. The vapor phase reactants such as halides react with oxygen in the presence of this furnace, in the presence of this temperature, and they are passed through the hot zone, and which is shown in the figure. See, you can see here the reactants such as metal halides react with oxygen in the presence of high temperature, and they will move inside the tube, and they will form the soot or glass particles. Porous glass particles are formed inside the tube. So the high temperature traversing torch is moved back and forth so that the glass particles will be deposited layer by layer on the inner wall of the silica tube. So this layer of silica particles forms the cladding. When the layer becomes sufficiently thick, then the vaporized chlorides of germanium or phosphorus are added to the gas flow to form the core of the fiber preform. You know that cladding should have a refractive index lesser than that of the core refractive index. So once cladding is formed, we have to increase the refractive index of the core section, so that we are providing vaporized chlorides of germanium or phosphorus, and once it is added to gas flow, then it forms the core of the fiber preform. When the desired thickness is achieved, the torch temperature is increased up to 2000 degrees Celsius, so that the tube will be collapsed and the original preform is formed. And once we got the original preform, we can give this preform into the fiber drawing apparatus in order to draw thin precise fibers. So this is all about modified chemical vapor deposition. Here deposition takes place inside the tube, and here soot formation is taking place. Okay. Next is the plasma activated chemical vapor deposition. And in the case of plasma, the experimental setup for the plasma activated chemical vapor deposition is shown here. Here you can see that there is no furnace for heating. Instead, we are using moving microwave resonator, and the glass tube is taken here. Glass layer is shown, and the reactants are SiCl4 plus O2 and dopants, and the reaction takes place inside the glass tube, and also there is a microwave, there is a plasma. It is provided by the moving microwave resonator. So there is no, here it is seen that there is no soot formation here. So let us go to the details of plasma activated chemical vapor deposition, or PCVD, and it is similar to the MCVD technique. And in the case of MCVD deposition, that occurs within the silica tube. Similarly, here also deposition occurs within the silica tube. In PCVD, a non-isothermal microwave plasma will be there, and that is operating at a low pressure, and this non-isothermal plasma initiate the chemical reaction. And along with the silica tube, there is a microwave resonator, and it operates at a frequency of 2.45 GHz. This microwave resonator forms the plasma, non-isothermal plasma. And this resonator generates plasma inside the tube, and this plasma in turn activates chemical reaction, and this process deposit clear glass materials directly on the tube wall, and there is no soot formation because there is no heating by furnace, and here there is no soot formation taking place, and thus so sintering is not required here. That means sintering, in sintering actually we are transforming the soot into original fine glass material without by heating process, without melting. Okay, so here there is no soot formation, so there is no need of sintering process, and when the desired glass thickness is achieved, the tube is collapsed into a preform, as in the case of MCVD process. And once we got the preform, we can draw fiber from this preform by using fiber drawing apparatus. And this is all about plasma activated chemical vapor deposition, or PCVD. And there are that means there are 4 methods for fiber techniques, fabrication techniques. So gone through all those techniques and find out the difference between all these techniques. Okay.